I want to show an example of a coding prompt that O1 Preview is able to do, but previous models might struggle with. And the coding prompt is to write the code for a very simple video game called Squirrel Finder. And the reason O1 Preview is better at doing prompts like this is when it wants to write a piece of code, it thinks before giving the final answer. So it can use the thinking process to plan out the structure of the code, make sure it fits the constraints. So let's try pasting this in. And to give a brief overview of the prompt, the game Squirrel Finder basically has a koala that you can move using the arrow keys. Strawberries spawn every second and they bounce around, and you want to avoid the strawberries. After 3 seconds, a squirrel icon comes up, and you want to find the squirrel to win. And there are a few other instructions like putting OpenAI in the game screen and displaying instructions before the game starts, etc. So first you can see that the model thought for 21 seconds before giving the final answer. And you can see that during its thinking process, it is gathering details on the game's layout, mapping out the instructions, setting up the screen, etc. And so here's the code that it gave. And I will paste it into a window, and we'll see if it works. So you see there's instructions, and let's try to play the game. Oh, the squirrel came very quickly. But, oops, this time I was hit by a strawberry. Let's try again. You can see that the strawberries are appearing, and let's see if I can win by finding the squirrel. Looks like I won.
The first example I have is very simple. This just counting the letter R's in a word strawberry. So let's start with the traditional, like existing model, GPT-4o. So as you can see, the model fails on this. There are 3 R's, but the model says there are only 2 R's. So why does this advanced model like GPT-4o makes such a simple mistake? That's because models like this are built to process the text, not with the characters or words. It's somewhere between, sometimes called a subword. So if we ask the question to a model, a question that involves understanding the notion of characters and words, the model can really just make mistakes because it's not really built for that. So now let's go on to our new model and type in the same problem. This is an O1 preview, which is a reasoning model. So unlike the GPT-4o, it starts thinking about this problem before outputting the answer. And now it outputs the answer. There are 3 R's in the word strawberry. So that's the correct answer. And this example shows that even for seemingly unrelated counting problem, having a reasoning built in can help avoiding the mistakes, because it can maybe look at its own output and review it and just be more careful and so on. My out is almost a code cracking of a badly corrupted Korean sentence. So here I pasted in the prompt, and I'm asking the model to translate this badly corrupted Korean sentence to English. And as you can see, this is not a valid Korean sentence. So let's start with the existing model, GPT-4o, and see how it does. The model is just not able to understand this text, which is a valid response because this is not a valid language. So what's happening here? So Korean is an interesting language in that when we form a character, we can combine vowels and consonants, sometimes put the consonant at the bottom, and so on. One way to corrupt this character is to add in some extra unnecessary consonants to it. And that combination is so unnatural to native speakers, so they can just, when they see it, just automatically undo that change and understand the text. So this is character level corruption. We can do that at the phrase level, we can also do that at the sound level, and so on. People have come up with various methods like this, and I found them really interesting, so I adopted a few of them to create this example. So if you understand Korean, this part that I'm highlighting now, you can read it off as a 지구상 어떤 번역기도 읽을 수 없지만 한국인들은, and so on. I'm not going to read off the whole thing, but this is the idea. Koreans can read it, but the models find it so difficult to understand. So now let's go on to our new model, O1 preview. and see if reasoning can help solve this problem. So I typed in the same thing. Unlike GPT-4o, this model starts thinking through this problem before outputting the answer. So it's decoding the garbled text. So that's actually the right approach, because I gave a translation task, but the underlying task is actually decoding this problem. So it started off with the right path, and then I'm examining this text, deciphering the text. Deciphering is actually the right verb to use here, enhancing the translation, and then actually it starts unpacking some part of it. So here, 모음과 자음의 다양한 변환으로, and so on. This is already an decrypted part of this, and then once the model figures it out, that part, everything else is just easy enough. So it does the other sentence too, and so let's close this thought. So it thought for 15 seconds. The final translation the model output is, no translator on earth can do this, but Koreans can easily recognize it. There's a method of encrypting Hangul by inputting various transformations of vowels and consonants. It creates a way to make it look different on the surface. It can even confuse AI models. I think this is a perfect translation of the sentence. So this illustrates how general purpose reasoning models like O1 Preview can help seemingly unrelated questions like this, which is almost like a code cracking. So I hope this illustrates how reasoning can be a powerful tool for solving your problems. We're starting a series of new models with the new name O1. And this is to highlight the fact that you might feel different when you use O1 compared to previous models such as GPT-4o. So as others will explain later, O1 is a reasoning model. So it will think more before answering your question. We are releasing two models, O1 Preview, which is to preview what's coming for O1, and O1 Mini, which is a faster, smaller and faster model that is trained with a similar framework as O1. So we hope you like our new naming scheme, O1.
So what is reasoning anyway?
So one way of thinking of reasoning is that there are times where we ask questions and we need answers immediately because they're simple questions. For example, if you ask what's the capital of Italy, you know the answer is Rome, and you don't really have to think about it much. But if you wonder about a complex puzzle, or you want to write a really good business plan, you want to write a novel, you probably want to think about it for a while. And the more you think about it, the better the outcome. So reasoning is the ability of turning thinking time into better outcomes, whatever the task you're doing.
It's been going on for a long time, but I think what's really cool about research is there's that aha moment. There's that particular point in time where something surprising happens and things really click together. Are there any times for you all when you had that aha moment?
There was the first moment when the model was hot off the press. We started talking to the model, and people were like, "Wow, this model is really great," and starting doing something like that. And I think that there was a certain moment in our training process where we trained put more compute in our RL than before, and train first of all generating coherent chains of thought. And we saw, wow, this looks like something meaningfully different than before. And I think for me this is the moment.
I think related to that, so when we think about training a model for reasoning, one thing that immediately jumps to mind is you could have humans write out their thought process and train on that. One aha moment for me was when we saw that if you train the model using RL to generate and hone its own chain of thoughts, it can do even better than having humans write chains of thought for it. And that was an aha moment that you could really scale this and explore models reasoning that way.
For a lot of the time that I've been here, we've been trying to make the models better at solving math problems, as an example, and we've put a lot of work into this, and we've come up with a lot of different methods, but one thing that I kept, every time I would read these outputs from the models, I'd always be so frustrated that the model just would never seem to question what was wrong or when it was making mistakes or things like that. But one of these early O1 models, when we trained it and we actually started talking to it, we started asking it these questions, and it was scoring higher on these math tests we were giving it, we could look at how it was reasoning. And you could just see that it started to question itself and have really interesting reflection. And that was a moment for me where I was like, wow, we've uncovered something different. This is going to be something new. And it was just one of these coming together moments that was really powerful.
Thank you, and congrats on releasing this.